Now, radioactivity and nuclear reactions. This is the first topic we are going to be treating this week. The exercise is from the all-inclusive calculations in physics. So every time a substance begins to disintegrate, it starts from an original quantity, NO. After some time, T, small letter t, the amount remaining is denoted as NT, and the amount that has decayed is denoted as ND. So we use the equation NT plus ND is equal to N is equal to NO to connect those three quantities. Also, another relationship we use is T is equal to small letter n times T is equal to small letter n times T half, where T is the time spent and T half is the half-life. N is the number of half-lives that has passed. Now, after that, another relationship we use is NT is equal to NO over 2 raised to the power n. Let's go straight to the exercise and start from question 1. Question 1 says, an element whose half-life is 3 years has n atoms. How many atoms would have decayed after 9 years? If the half-life is 3 years, we write that T half is 3 years, and the time passed is what? 9 years. So we are looking for ND, the number of atoms that has decayed. So ND is question mark, and we also don't know amount of substance remaining. So we write NT also question mark. Using T is equal to N times T half, we can easily see that 9 will be equal to N times 3, because 9 is the small letter T here. 3N will be 9 and N is 3. So NT is NO over 2 raised to the power n from the top right corner here. NT will be N over 2 raised to the power 3. And the question we are given that the original amount is N. So that means NT, amount remaining, becomes N over 8. NT plus ND is NO. Now using NT plus ND is NO. Our amount remaining is now N over 8. Amount that has decayed is ND. So N over 8 plus ND is N, which is the original amount. So ND will be N minus N over 8. If we simplify this, we get ND is 7 over 8N. So the fraction that has decayed is 7 over 8 of the original amount. Also, number 2 says the half-life of a radioactive isotope is 9 days. Find the amount which has decayed after 36 days. Question 2 is the same as question 1. We use T is N times T half. 36 is N times 9. T half is the half-life. So 9N is 36 and N is 4. Now using NT is NO over 2 raised to the power n, we have NT is N over 2 raised to the power 4, because it is 4 half-lives that has passed. This small letter n refers to the number of half-lives that have passed. So we get NT is equal to 1 over 16N. Let N be the original amount. Now using ND plus NT is NO, ND plus 1 over 16N will be N, since N is our original amount. And we get ND is N minus 1 over 16N. ND is equal to 1N. N is the same thing as 1N minus 1 over 16N. If you factorize N from both, you will have 1 minus 1 over 16 in bracket, and the amount that has decayed is 1 over 15 of the original amount. Question 3 says the half-life of a substance or a radioactive isotope is 4 days. Find the amount which has decayed after 16 days. Question 3 is exactly the same as questions 1 and 2. Just look at the steps well, and it's going to be clear, very clear to you. Number 4, T half is 20 hours. Half-life is 20 hours. The half-life of an isotope is 20 hours. We are looking for the amount remaining after 80 hours. Let's first go ahead and find the number of half-lives that have passed first. 80 is N times 20, because 80 is our time passed. N is the number of half-lives times 20 hours, which is the half-life. So we get N is 4. Using NT is N over 2 raised to power N. We get NT is equal to NO over 2 raised to power 4, since 4 half-lives have passed. So the amount remaining NT is NO over 16. And that's the same thing as 1 over 16 of the original quantity is left. Let's take a few quick notes. We call nuclide. Nuclide. You hear what I was saying? We hear nuclide all the time in radioactivity. It means the same thing as nucleus. Sometimes we also hear nuclei, which is Nuclei. Nuclei is a plural of nucleus. A nucleus is a specific atom with known number of protons and neutrons. Nuclide is also the same thing as the plural of nuclide. Number 3 is nucleons. Every time we hear nucleons, nucleons refer to constituents of the nucleus of an atom. So, the protons and neutrons. Every time we hear nucleons, it means protons and neutrons in an atom of an element. So, nucleon number means the number of protons and neutrons in the atom of an element. Nucleon number 4 means total number of protons and neutrons in an atom or in a nucleus. So the nucleon number of an atom is also the same thing as the mass number. Number 5, we also hear nuclide symbol. The symbol for a nuclide is Az, where A is the mass number of protons plus neutrons, and Z is the atomic number of protons. We also always hear decay, disintegration, and so on, or radioactive disintegration. It means the same thing. They all mean the same thing. Decay means disintegration. Disintegration also means the same thing as radioactive disintegration or radioactive decay. NO is the original amount or original count rate or original mass or original quantity of a radioactive isotope. So those are the few basics. We'll be able to do numbers 5 and 6. They are very simple.